So hello everyone, this is a question in GATE Physics 2012, which is a 1 mark question, quite a simple question. This is question number 6, which states that the isothermal compressibility kappa of an ideal gas at temperature T naught and volume V naught is given by. So these are the four options. In order to understand these we will be dealing with the concept of both thermodynamics. As you can see that ideal gas at temperature T naught and V naught is given here. And another important concept is the isothermal compressibility, something related to the bulk properties of the fluids. And which is the fluid here? It is the ideal gas, which is given in the question. So let's see what is the detailed solution of this particular problem. So this is the question, just I have written the question again, that the isothermal compressibility of an ideal gas at temperature T naught and volume V naught is. Simple question, not require too much of thinking because it's just the formula which is important here. But I have given a detailed solution to understand what exactly it is. So I have written here the concept used here is the thermodynamics as well as the properties, the bulk properties of the fluids. The important thing in order to understand the compressibility is that first thing which is required to be known is the bulk modulus of elasticity. So what is the bulk modulus of elasticity? It is defined as the ratio of the normal stress to that of the volumetric strain within the elastic limit. So any definition of the modulus of elasticity, such as Young's modulus, bulk modulus, shear modulus, all these moduluses, they generally are valid in the elastic limit. So this bulk modulus is one of the modulus of elasticity. So what happens is that suppose you have I have drawn here a spherical volume, but if you have a cube or a cuboid, suppose in this way. So if you are applying force per unit area, that is stress from the outside to this particular volume, that is actually the normal stress. Why? Because it is perpendicular to the area of the cross section. You see, this is the area, and you are applying the stress or the force per unit area perpendicular to it. But sometimes it may be possible that in this same cube or cuboid, you apply the stress in this direction parallelly to this particular area of cross section. Area's direction is normal, outward normal. So if you apply the stress or the force per unit area in a parallel direction, this results into shear. And corresponding to this, the modulus which we will get is the shear modulus. But in the upper case, this first case, we will get the bulk modulus. So what is bulk modulus? So as you can understand that in case of a fluid, such as ideal gas, which is mentioned in this question, the force per unit area which is applying on the ideal gas will be definitely the pressure. That is quite clear within the thing. So if you apply, suppose this is a spherical volume, this is the original volume, which is in the outside, this broad solid line which is present. And if you are giving the stress, normal stress, that is in each direction you are giving the normal stress from the outside, then it compresses this volume which was earlier here, it changes by V minus delta V. So there is a negative sign which we can see here, that there is change in volume will be always negative. Why? Because it is always resulting into a decrease in the volume when the force is applied from the outside. Therefore, there will be a change in the volume and that change will be negative. So we will be using that negative sign as well. Therefore, as the definition says, that it is the ratio of the normal stress to that the volumetric strain. Let us see one by one what is the normal stress. So normal stress in case of this ideal gas which is given here is force per unit area. That is nothing but the pressure. The pressure which if you have a container in which suppose the gas molecules are there, and you through the piston you are pushing this particular, or you are applying the pressure on the gas from the outside, and you can see that there will be a change in the volume in the gas. So that change in volume or the stress is nothing but this pressure, or the normal stress is nothing but the pressure which is applied on the gas, and volumetric strain is Due to the pressure which is applied, there will be some change in volume with respect to that of the original volume. So volumetric strain, as the definition of the strain, so it's delta V by V, the change in volume to that of the original volume. Simple. Therefore, the bulk modulus comes out to be the stress, that is the pressure, divided by the strain, that is the delta V by V, and this negative sign is actually representing, so let me change the color. This negative sign is actually representing increase in force decreases volume. Increase in force from the outside will decrease the volume. That's why there is a negative sign. And finally, we get as some differential limit, we get minus V delta P by delta V. Just you can see that V is in the denominator, it is delta V by V. So V will come in the numerator. So it will be V minus V and this P. So change in the pressure and change in volume. So delta P by delta V. This is a differential limit. Therefore, this is the bulk modulus, the definition of the bulk modulus. Compressibility is actually defined as the reciprocal of the bulk modulus. So it's the reciprocal of the bulk modulus, and therefore we can write the compressibility as minus 1 by V delta P, just the opposite of the bulk modulus. So this is the definition of the compressibility. But in this question, there are certain terms and terminologies which are used in this question, that is V naught and T naught. They have mentioned. Therefore, isothermal compressibility. Isothermal means at constant temperature. At constant temperature. So isothermal means at constant temperature. So this bulk modulus or the reciprocal of this bulk modulus at constant temperature is given by this. So minus 1 by V naught delta V delta P. V naught, why V naught? Because V naught is given in the question. So there is the original volume. Therefore, this V is the original volume. We have to replace it with V naught. And delta V by delta P as it is, but at constant temperature T or T naught. So this becomes the compressibility or isothermal compressibility. So this is the isothermal compressibility which we require to find. So the correct option is answer A, as you can see in this question. It is minus 1 by V naught delta V by delta P at T naught. So this is the correct option. So A is the correct option of the isothermal compressibility kappa of an ideal gas at temperature T naught and V naught.